Welcome back, my students, to Chapter 6, Biochemistry. What does it mean, biochemistry? Biochemistry is a branch of chemistry that studies the biochemical compounds and their reactions in the body. The main biochemical compounds are carbohydrates, lipids, it is fats and oils, proteins, vitamins, and enzymes. What are the functions of these biochemical compounds? The main functions are producing energy, building the tissue of the body, and protecting the body from diseases. We have essential compounds in the human diets. What are they? We have carbohydrates, lipids, fats and oils, proteins, vitamins, water and minerals and salts. What are the main processes in the body? The first process, we call it digestion. It is the breaking up complex polymeric compounds to smaller ones to be absorbed to the blood. Means if you have a very long compound, this very long compound can be broken down into smaller ones to be absorbed to the blood. This process we call it digestion. Example, when you eat proteins are digested to amino acids. It means to break this very long compound of proteins to smaller ones, what you call them? Amino acids. These amino acids are absorbed to the blood. The second process, we call it building up. It is the opposite of digestion. Building up means combine small molecules to form larger ones to build the skeleton and the muscles of the body. If we repeat the first example, amino acid and amino acid combine with each other to give a very long compound. What is it? It is protein. So it is the opposite of the first one. This one, long compound, changes to smaller one, but this one, small molecules, are here we have combine with each other to give us a very long compound. What you call this process? Building up. The third process, it is producing energy needed to do all the vital activities of the body. And the fourth one, the regulating the processes and producing hormones and fats in the body. So we have four processes, main processes: digestion, yes, number 2, building up, number 3, producing energy, number 4, regulating the processes. We start with the first biochemical compounds. What you call them? Carbohydrates. Carbohydrates, they have another name. We call them saccharides or sugars. What are the carbohydrates? They are mono or poly molecules of aldehydes or ketones with many hydroxyl group. Mono, it means one. Poly, it means many. So mono, one, or poly, many molecules of aldehydes or ketone. maybe aldehyde or ketone, with many hydroxyl groups. The aldehyde groups, or the functional group of aldehyde, we can write it CHO or C double bond OH. CHO, not COH. CHO or C double bond OH. It is the same. Ketone, the functional group, it is C double bond O without H. This one between two carbon atoms, but this one it is terminal. C double bond OH. Hydroxyl group, it is OH. Here we have the example. Look, compound, they contain aldehyde, so this is aldehyde. You can write it CHO or C double bond OH. The same. CHO or C double bond OH are the same. So maybe we have aldehyde or ketone. This is C double bond O, it is ketone group. So maybe you have aldehyde or ketone, not both. And then what we have, many hydroxyl group. So we have OH, 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 and OH. Okay, now you have to focus on, can we write OH, as we want? No. In glucose, OH at carbon number 3 is written left side, and the other OH, all of them right side. Or you can write the opposite. All of them left side and OH number 3 right side. So you have to focus on this one. Yes, look. This is OH number 3 left side. And the other OH, all of them right side. If I write it, okay, maybe you will change this one left side, so the name of this compound changes. Now here we have the glucose. We can write it like this one or this one, the same. CHO or C double bond OH, C double bond OH or CHO, it is aldehyde group. This one distinguish glucose. What about the fructose? Here we have C double bond O, so this is ketone. So in the fructose we have ketone group. But look, from carbon 3 to carbon number 6, the same as in glucose. So this is glucose and this is fructose. The difference only between them, the functional group. The functional group C double bond O, it is ketone group between two carbon atoms. It is at carbon number 2, always at carbon number 2 here for the fructose. And the functional group for glucose, it is terminal. It is at the end of this compound. And here we assign it with 1. And the functional group here, it is carbon number 1. But the functional group here, it is the carbon number 2. When you notice this one, okay, glucose and fructose, they have the same carbon and the same hydrogen and the same number of oxygen. So they have the same molecular formula. If you count how many carbon atoms, you will find 6, hydrogen 12, and oxygen 6. But they have different structure formula. So in the structure formula, we have different structure formula because we have different functional groups. But they have the same molecular formula. The molecular formula C6, H12, O6 are the same in glucose and in the fructose. So you have to focus this point, it's very important. If the question is glucose and fructose have the same molecular formula, yes, it is true. If they have different structure formula, yes, this is true. They have different functional group, yes, this is true. So what is the functional group of glucose? It is aldehyde. What is the functional group of fructose? It is ketone. In general, carbohydrates contain carbon, hydrogen, and oxygen. So the general formula is CnH2nLON. N, it means any number of carbon atom, but not 1 or 2. It starts from carbon 3. So if this is 3, okay, we have 6 and this is 3, the same number. Or you can take, n as a common factor. What will, yes, if the n is common factor here, we will get CH2O. CH2O by n, it is any number of carbon atom. So this is the general formula of carbohydrates. As we saw here, we have C6, so this is a number, and this one is double the number, and here it is the same number of carbon. So oxygen and hydrogen, carbon and oxygen have the same number, but the hydrogen, it is double this number. Okay, what are the ratio, okay, between the carbon, the hydrogen and the oxygen? What is the ratio of hydrogen to oxygen? The ratio of hydrogen to oxygen in this compound, what is this compound? Yes, they are carbohydrates. Is 2 to 1, as in what? As in water. So again, the ratio between hydrogen to oxygen is 2 to 1. If you have any number, yes, so for the oxygen any number, so this is double this number. If you subtract this one, yes, what we have here divided by n, okay, you will get 2, and this is divided by n, you will get 1. So as in what? As in water. As we see here, it is H2O, 2 hydrogen and 1 oxygen. This is example C6H12O6. Okay, so we have 12 hydrogen and 6 oxygen. If you want to take the ratio between them, you will get 2 to 1. Or you can write it like this one, CH2O by 6. Name of carbohydrates. What does it mean, carbo and hydrates? Hydrates of carbon. It is hydrates of carbon. Hydrate, it is water. And carbon, it is the carbon atom. That's why we call it carbohydrate. Why? Because in the past, scientists thought that there is a chemical bond between hydrate, it is water, and carbon. By the way, here hydrate means water and carbon. So they named as carbohydrates. So scientists thought that there is a bond between carbon and water. Although now we know no bond between water and carbon, but the name doesn't change. It is like this one, carbohydrate. They thought that this is Cn, any number. They thought that there is a bond between this carbon and H2O. But now we know there is no bond between carbon and H2O. The bond is between carbon, OH and H. OH and H. As we saw here, look. Okay, look. The bond between what? Carbon and OH and H. It is not H2O. This is okay, OH, and this is another one. But they thought that there is a bond between this carbon and water. Here, they thought that here it is written as H2O, not OH. That's why they call it what? Carbohydrate. Now, if we take glucose, this is C6H12O6. It can be written as C6H2O by 6. They thought that there are 6 carbon atom and 6 water molecule. But now we know that this one, it's not true. But the name is still up to now. What are the exceptions of the general formula of carbohydrates? We know the general formula is CnH2nLON, but we have some exceptions here. This compound C2H4LO2 and also C1H2LO1, but it's not in our syllabus. We have only in the syllabus C2H4LO2. It has the same formula, look, the same formula, but it is not carbohydrate. So this one, what you call it? Acetic acid. We have 2 carbon atoms, CH3COH, 2 carbon atoms, and this is 3 hydrogen and 1 4 hydrogen atoms, and 2 oxygen atom. So here we have the same formula, but it's not carbohydrates. As I said, carbohydrates start from carbon 3. So carbon 1 or carbon 2, they are not carbohydrates, although they have the same formula. Another exception, this compound, look, C6H12O5. We expect this one 6, but this is an exception. We have only this formula, rhamnose sugar. It decreases by 1 oxygen atom, although it doesn't have the same formula, but it is carbohydrate. Again, the first one doesn't have the same formula, but it's not. This one it have the same formula, but it's not carbohydrates. The second one, it doesn't have the same formula, but it is carbohydrates. So this is the opposite, and just we have to know only these 2 exceptions. We have a lot, but these are in our syllabus. What is the importance of carbohydrates? Carbohydrates are the source of energy in the body. So they produce more than half of the energy the body needs, because they can be digested easily inside the body. So here we have to notice that when marathon runners preparing for the race, they eat large amounts of bread and macaroni, which are good sources of carbohydrates. When they run, these carbohydrates or bread and macaroni burn inside the body and give them energy. So this is as a storage of what? Of carbohydrates. Where we can find carbohydrates? Carbohydrates are found in plants in large amount. It is 70% of the weight of the plant is carbohydrates. They are present as starch, cellulose, or inulin. Sometimes also the gum. In the animals, in small amount in animals within human beings. Okay, they are found in blood, liver, and muscles.